Imagine, you're a mountain climber, lost in a fog. Yeah, just a tiny bit of visibility, and your only goal is to, always move up.
It's like every step you take must literally be higher than the last one, right?
Exactly. And, um, that's the core of what we're chatting about today. This idea of a greedy pursuit of up in AI, known as hill climbing.
Right, the algorithm that always picks the best immediate move, hoping it gets you to the highest peak.
Yeah, but here's the snag. What if that peak you're on is actually just a little, sub-peak, a local maximum, while the true summit is hidden behind a valley? It's like you've reached the
Yep.
top of a small hill and think, I've arrived, but then you're stuck.
So the algorithm just stops because all it sees is downhill all around, right?
Exactly. It's a real conundrum in optimization problems. In AI, we're dealing with astronomical numbers of possibilities, like picking the fastest route for a truck, visiting 100 cities. The number of combinations is, like more than the atoms in the universe.
Whoa, that's insane. So it's basically trying to find that one optimal solution in a gigantic search space without exploring every possibility.
Yup. And the algorithm's simple command is just go up. It doesn't look ahead. It only cares about the next immediate step, its local view, if you
hmm
will.
I've always found that greedy approach fascinating, but also somewhat short sighted.
Exactly. Which brings us to the traps of hill climbing. The first trap, well, is what we just talked about. The local maximum. It's like reaching a false summit, where the climber thinks they've won, but really, they're on a tiny foothill.
I mean, it's like celebrating because you saw a peak, but then you realize the actual summit is completely out of view because of the fog.
Right on. Then, there's the plateau trap. Imagine, you're in a flat area where every move gives you exactly the same elevation. No move is higher than your current spot, so the algorithm gets stuck because, well, there's no improvement to be found.
Yeah, flatlands where every neighboring point is just the same altitude, it really halts the progress.
And don't even get me started on the ridge trap. Picture a narrow ledge where only one, diagonal move could actually be upward. But if you're limited to checking only the obvious cardinal directions, you'll miss it entirely.
That's pretty wild. So, in all these cases, the algorithm stops, even though there's a better solution if it took a worse step first.
Exactly. It's all about, the trade-off between speed and perfection. Hill climbing is super fast, using hardly any memory, ideal, when you need a good enough answer in seconds, but its blind spots are, well, its fatal flaw,
Yeah, it's like trying to find a needle in a haystack when you're only allowed to look at one straw at a time.
right? And because the search space in many problems, like optimizing hyperparameters for machine learning or even finding new drugs, is immense, you can't possibly examine every route.
Definitely. So, what do researchers do? I mean, is there a way to help our poor, foggy climber avoid all these traps?
Great question. They developed clever solutions, starting with random restart hill climbing. When your climber gets stuck on a local peak, you literally, pick them up, like a helicopter, and drop them in a new random spot to start the climb all over again.
Interesting. So, by trying multiple random starting points, one of these climbs may actually hit upon the true summit.
Exactly. It's like running the algorithm hundreds or thousands of times and, yeah, keeping the best result. Now, another upgrade is stochastic hill climbing. Instead of always choosing the absolute best neighbor, the algorithm picks randomly between all the better moves.
That adds a twist. I see. It forces a bit of exploration, so even if the climb isn't perfectly steep, it might be the path that leads, eventually, to more promising ground.
Precisely. And then, for the bold move, there's simulated annealing. Now this one is, a game changer. It allows the algorithm to sometimes take a downward move, you know, a step that seems worse, to later find a much better path.
That sounds counterintuitive at first, but it's like sometimes you need to go down a little in order to climb higher later, right?
Exactly. It's like saying, hey, I'm willing to take a slight detour if it means I'll eventually get to a bigger climb. It borrows from the process of metallurgy, heating up metal and cooling it slowly. The algorithm starts with a high temperature, accepting worse moves with a certain probability, and then cools down, gradually behaving like strict hill climbing.
Yeah, that's a neat analogy. So, in essence, simulated annealing is the algorithm that learns that one step backward can be the key to taking 1,000 steps forward.
That's the spirit of it. And these enhancements, they're not just theory. They have real-world applications in solving NP-hard problems like the traveling salesman problem or optimizing neural network parameters.
Right. In a way, every time we see these complex optimization challenges, someone's been tweaking hill climbing to make it more robust.
Exactly. The fact that a simple idea like just go up can lead to so many innovations is part of its genius. But it's also a humbling reminder of the limitations inherent in local search strategies.
Absolutely. One thing I find a bit challenging, though, is sometimes claiming that these algorithms are good enough. Would you say that relying on hill climbing and its variants is somewhat of a leap of faith?
I see what you're saying. It's like, while they work amazingly well in many cases, they don't guarantee finding the absolute global maximum. They are trade-offs, speed versus perfection. You're essentially betting that a good enough solution is close
Yeah,
to
I
the
get that.
optimal one.
It makes me wonder if, in some high stakes scenarios, taking that risk might be too dangerous. Did you ever feel like there's a better strategy beyond these heuristic approaches?
Well, that's the million-dollar question in AI research. While these heuristic methods are incredibly useful, there's ongoing work to develop even more intelligent strategies that can balance the trade-off sharper. But at the end of the day, every algorithm has its Achilles heel, even if it's just a clever workaround like random restarts or simulated annealing.
It's a brilliant testament to how, in AI, being smart enough to know your limitations can spur innovation.
Absolutely. It's like training yourself to not be fooled by a false peak. Every challenge forces us to invent new mechanisms, kind of like, adaptive behaviors in humans when tackling, say, a new mountain.
Exactly. And I love how it all circles back to that basic yet profound notion. Sometimes the simplest ideas reveal the deepest challenges.
Right on. Like our climber, with just one rule. Go up. But that simple rule opens up a whole discussion about search spaces, optimization, and the clever tricks we use to avoid traps.
Wow, it's fascinating how something so intuitive leads to such rich discussions and innovative work in AI.
Yup. And if you think about it, this balance between rapid, efficient decision-making and the risk of getting trapped is at the heart of many intelligent systems. It's all about knowing there's more to the climb than meets the eye.
Definitely, yeah. Well, I gotta say, this whole metaphor of a fog covered mountain and our stuck climber really drives home how even the simplest instructions can lead to complex challenges in smart systems.
Absolutely, and it's a reminder that while our AI algorithms are fast and efficient, they still often require a bit of creative problem solving to overcome their limitations.
Thanks for shedding light on this tricky balance between speed and global optimization. It definitely gives us a lot to ponder, especially with all the innovations this space is seeing.
For sure. And keep in mind, each improvement, whether it's random restarts or simulated annealing, is a step toward making our AI and our understanding of these systems that much more robust.
Absolutely. All right, folks, if you found this discussion enlightening, remember that every peak we conquer in AI is just another mountain that awaits.
Exactly. Thanks for joining in this expedition. Keep exploring, keep climbing, and don't forget to celebrate even the small wins along the way.
Until next time, stay curious and keep reaching for those unseen summits.